Physics Part 122. In general, the average spacing of atoms in liquids is up to about twice that in the solids, or still of the order of 10 raised to minus 10 meter. For gases, the average spacing is of the order of 10 raised to minus 9 meter. We've got an example for you, assuming that the atoms in the iron are arranged in a simple cubic lattice. Estimate the spacing between the atoms in the iron. The density of the iron is 77,900 kilogram meter per parts raised to minus 3, and its molar mass is 56 into 10 raised to minus 3 kg. 1 mole contains Na is equal to 6.0 into 10 raised to 23 atoms. From the density of the value, we know that 1.0 meter cubic has a mass of 7,900 kilogram, which is 7,900 kilogram divided by 56 into 10 raised to minus 3 is equal to 1.4 into 10 raised to 5 mole. This contains 1.4 into 10 raised to 5 into 6.0 into 10 raised to 23 is equal to 8.5 into 10 raised to 28 atoms. If these atoms are arranged regularly in a cubic lattice, along one side of the 1.0 cubic meter cube, there will be under root 8.5 into 10 raised to 28, which is equal to 4.4 into 10 raised to 9 atoms. But the side of the cube has a length of 1.0 meter, so the interatomic spacing is 1 over 4.4 into 10 raised to 9, which is equal to 2.3 into 10 raised to minus 10 meter. Because we have made an assumption about the simple cubic arrangement of the atoms in iron, which is not in fact true, we should not give this estimate to more than one significant figure, interatomic spacing of 2 into 10 raised to minus 10 m. You can carry out this calculation for the other metals too. Now it's your turn. Estimate the interatomic spacing in aluminium, for which density is 2,700 kilogram cubic meter and the molar mass is 27 into 10 raised to minus 3 kilogram. The unit cell of a simple cubic lattice, this cell is repeated regularly throughout the crystal. Crystalline and non-crystalline solids. We have already made use of an assumption that in metals like iron and aluminium, the atoms are arranged in a simple cubic lattice. The regular arrangement of atoms or ions in the lattice is characteristics of crystalline solids. The crystalline solids include materials that we would immediately recognize as having a crystalline form, such as common salt or sugar, and also metals. The crystals of which a metal such as iron is made are not metals. The crystals of which a metal such as an iron is made are not immediately visible. The normal form of a metal is polycrystalline, that is consisting of a large number of small crystals. The atoms within each of these small crystals are arranged in a regular lattice, but the small crystals are arranged randomly with respect to one another. It is possible to grow large single crystals of the metal in which a single lattice continues right through the solid in just the same way as in the large crystals of common salt. A polymer is a solid made up of very large molecules, usually a compound of carbon. These molecules often take the form of long chains, sometimes with cross links to the neighboring chains. If the polymer shows a certain amount of the order, for example, if the chains are parallel, the material is sometimes referred to as a crystalline polymer, but the order is not given as provided over here in the figure. and it is usually not a perfect one either.